Vectors in Kinematics Introduction. You can use two-dimensional vectors to describe motion in a plane. We have already looked at the vector analogues for some of the equations used with constant acceleration. V equals u plus at and r equals ut plus a half at squared. In these equations, u is the initial velocity, and in this case, an initial velocity vector. V is the velocity at time t. A is the acceleration. R is the change in displacement in t seconds. So we're at some initial position and we move with an initial velocity and an acceleration for some time t, and the r that we get from this equation would be the change in displacement in that time. If a particle starts from the point with position vector r0, then we can give r is equal to r0 plus ut plus a half at squared, where here r is the absolute position relative to an origin at time t. So without the r0, we get the change in displacement, but with the r0, we now know exactly where the particle is. If the particle is moving with constant velocity, in other words, the acceleration is 0, then of course we lose this term, and we just get that r is equal to r0 plus ut.